Hello, I'm JW. This time it's failed electrical products, and here's the product in question, and it's some kind of LED lighting thing, and this has been sent in by Urban Harvey Exploration, and unsurprisingly the product was obtained on eBay and it was shipped from a seller in China. So let's have a look and see what's wrong with it. Now here's the product in question, and essentially it's one of these strips of LEDs. Here's the individual elements inside there. Just a resistor ever so far to limit the current, and it's encapsulated in this sort of flexible plastic tube type material. And at the end here we've got this sort of sealed white module, which is presumably some kind of power converter, and then we have a plug on the end there, so you just plug that straight into the mains and the thing supposedly lights up. Now that seems innocent enough, but of course there is a problem with this product. In fact there's probably several, and here's the note which was sent in with the item. And as you can see, it says it's from Urban Harvey Exploration, and I bought some LED light strips from eBay. They came from China, and when I got them I was not happy with the final product, so contacted the seller about this, but did not get very far. Well, that's no surprise. So basically this is what he wrote to them. So on the end where the power cord plugs onto the light, there is sellotape wrapped around the end to keep the power cord from becoming lost, and on the other end is the same. Yes, sellotape, that's right. So bearing in mind this is mains voltage equipment, here's the one end here, and as you can see, yes, it's just got a bit of some kind of adhesive tape stuck over the end, so that's pretty poor. And the seller apparently said this here, I've just checked this, the tape was for protection and you'd better keep it when you use it. It would do no harm to the strip, never mind about harm to the individual using it, and you can still use it in the safety way. Have you tried the strip? Will it light up? Well, let's see now. So pretty poor, and there's no here about the fuse in it. This is a 13 amp plug, but obviously this is not going to take 13 amps in terms of the lighting, so we'll have a look at the fuse inside as well. So let's first of all see if the thing actually works, and then see what's actually wrong with it. So here's the product here. It comes with a plug already fitted, and just a question of plugging that into a suitable socket, and it lights up. Now this doesn't actually look all that bright, so not entirely clear what these things are supposed to be used for. This is a cool white item. Let's see, the LED is just illuminating there, though something in the middle here seems to have gone a bit wrong, because I don't know that will show on the camera, but this section here certainly looks a lot dimmer than the others. In fact, some of these LEDs look considerably duller. That one in there looks rather yellowy, so pretty obviously there's a bit of issue with consistency on this thing. They're certainly brighter at the ends and not in the middle, so that may not show on the camera all that well. But in any case, the whole thing is not particularly bright. As you can see there, it's not sort of overpowering anything. And you can see here there's an issue with that one. It's considerably dimmer than the rest. And as we go along again, there's one here, which again is far dimmer than the rest of them. So certainly quality does not appear to be top on the agenda of this product. Now let's just put the electricity away there. Now what we've got here then is a 3-pin plug here, standard UK variety, and on the back it says unbreakable. Is that a statement or a challenge? But I could break it. And a bit of flex there. Then we have this sealed white blob, which has no fixings visible on it. It does have some markings on there, so let's have a quick look. They're probably all fake, but we'll have a look anyway. Now this may be difficult to see, but let's see what we can find. So we've got double insulated there, or class 2, CE, which is far too close together, and ROHS, which is supposed to indicate it's not full of lead or something like that. And basically that's the whole thing. The back has nothing apart from those 6 holes, and the front has 2 holes. But again, there's no visible screws. It appears to have been sonically welded together. And continuing on from this, we've got a bit more wire here, and you can see inside clearly the 2 wires coming out of that. And then we've got the strip which starts here, and as you can see this is just some kind of adhesive tape here, which apparently is used to hold the thing together. And then the other end is some sort of cap on there, and as you can see, once again, the sort of adhesive tape used to attempt to fix the end on. So if we take the tape away, and bearing in mind this is just the normal sort of adhesive tape you can buy, and it doesn't have any particular insulating properties. It's also the kind that goes yellow and brittle and falls off after a fairly short time, especially if it's left in the sun or in a brightly lit environment. So that's pretty poor. Now, this end cap does just pull away there, and inside you can see the end of the strip. Now, the tubing is actually fairly thick, which I suppose is something, but of course the end just pulls away, and bearing in mind that tape doesn't hold anything at all. See the end of the solder connection there. And of course the other one's going to do exactly the same, it's simply just taped together. Now let's have a look inside this plug and see what we've got in here. The pins do appear to be at least brass coloured, and they are sleeved, so I suppose that's something. And inside here, no earth, of course, just the line and neutral. I've got this fuse here which doesn't look particularly wonderful. 13 amps, which again is grossly overrated. This flex certainly is not going to be rated for 13 amps, that's sub 1 square millimetre, 0.75 probably. So here's that fuse, very generic sort of markings, not printed very well. BS1362, which is theoretically the right standard, 250 volts and 13 amps, but say no maker's name anywhere, and certainly doesn't exactly give much information there. So, and again, 13 amps is the wrong value anyway. The plug isn't actually too bad as these things go, it's fairly standard fare there, but so it's MS, it says in the middle. Various other markings on there, so that's not too bad, at least the pins do appear to be brass, so that's reasonable. But say these are very cheap anyway, and it's made of that sort of thin sort of plastic, some claiming to be unbreakable on the lid there, but yeah, so it's fused on the lid with the kite marker, though whether that's genuine or not is anybody's guess. So I think we'll just remove the plug completely from this, and then we'll do a few tests on the actual device itself. So just remove the plug from the end there. Looks like someone has actually put some solder on the end of the wire. That's a pretty poor thing to do, because when you put solder under a screw connection, of course solder is very soft, and the tends to creep under the pressure of the screw, making a loose connection. The flex itself is marked. It's claiming to be 2 core 0.75 square millimetres, as I surmised earlier. And then it goes to this blob, and then straight into the actual LED strip. So we've got some tape here, so what we'll do is just cut that away. Bearing in mind, tape is not a suitable method for securing items together, as although it's sticky and holding it down at the moment. That can obviously change at any time. As you can see, it just pulls out of the end. Basically got sort of two contact bits inside there, and then inside here you've just got the 2 pins which press into that, so that will be easy to pull apart at any time. And then the strip itself is say just a plastic rectangular section tube, probably PVC or something, with the LED strip contained inside, and it's a single colour, so just the 2 tracks on the back, the positive and negative. So the end here is basically a plug of sorts, and you can see the 2 pins there, but I can easily touch both of those with my finger there. A thumb in there as well, so that's pretty poor. This is actually one moulded piece, despite the fact that there's this sort of ridge in the middle, and then it just appears to be glued or fixed over the end of the flex just there. So that definitely is not good. So let's see if there's any kind of connection between this end and this end. Bearing in mind you've got your 240 volts here. So what is coming out of that? Now obviously just removed the plug earlier. I've put this brown tape on this end just to indicate that that is the mains input, and then the other end is just 2 wires poking out, which of course would have connected to the strip. So what we'll do is just see what kind of voltage this thing puts out. So I've got the meter here, and we'll put it to that setting there, which is a low impedance mode there, and basically covers any kind of voltage you care to mention. So let's just connect up. Now I would imagine the output of this is going to be DC, because of course LEDs generally don't like AC. So we'll stick that over there, and then this end we'll just shove into the connection block here. And this is running from an isolating transformer as well, because obviously we don't necessarily know what is going to be happening at the top end. So let's see what we get. Well, that's lovely, isn't it? So at the end there we've got 251 volts DC, and it appears to be negative. So that's not very good. I have actually connected the wires the wrong way around there. So let's just put those the other way around, it will be helpful. Well, so just connect here, and of course connect there. So say correct polarity there, then say they're also using the blue there as the negative terminal, and just close that down. So there you go. So mains there, and the output is 251 volts DC. Now if you poked your fingers there, then that's going to be pretty bad news, because 250 volts DC is certainly at lethal levels. So of course we're not going to be touching that. And despite the fact it's isolated, of course if you touch both of those, then it doesn't make any difference. And bearing in mind the end of this had the two pins there, one right next to the other, so very easy to touch both of those. So that's pretty poor. Now what was there was on the what's this sort of auto volt setting and the low impedance input. So I thought we'd just try this on the AC and the DC settings as well. So same as before, just got the two wires there and the power supply. So this is on AC, or AC volts. So we're reading there about 88 volts AC. That's not what I would really want. And that's actually come out at 100 Hertz. Now that suggests there's some kind of half wave or some kind of rectification going on there, because that's double the mains frequency. So we've got 100 Hertz AC coming out of there at about 80 volts. Yeah, 88 volts or so. Now let's just check that on the DC setting. And sure enough, it's coming up as 243 volts DC. So it appears then that all that's inside of here is basically a rectifier, and of course it's reading both of those things because it's really poorly smooth, so no capacitors obviously. So I'll probably find it's just 4 diodes or something very similar. Now let's just see if it's actually referenced to the mains. So we'll just need some additional wires for that. So we've got here's the same thing, got the mains here, got this additional wire here from the line there, just into this block so I can just probe in there more easily. And the output we've got 1/2 connected to the blue lead there, and we're on AC volts again. Now if this was a properly isolated supply, there would be absolutely nothing between here and of course here, because of course this is 1/2 and then that's isolation and that's the other half. So let's just see if that's true or not. Now it's saying 1 volt, let's just pick up in the leads there. So there we have 105 volts AC, and that's between one side and the other, so it's definitely referenced to the mains. And certainly if you touch the end of that, you would get a shock of about 100 volts AC. Now that's not necessarily going to be fatal, but the point is that's not something you're going to want. That is certainly going to be rather painful. And that's at the 50 Hertz, so mains frequency. Now let's try the same thing again, but referencing it to the other side, or the neutral in this case. So let's see what we've got. Yep, 106 volts there as well. So both sides are obviously some kind of connection there. So just for completeness, we'll just do the other side. So we'll go from the brown wire there. Oh yeah, this is to the neutral inside there. Yep, 105 volts AC. That'll be the same at 50 Hertz there. And of course we know what the answer to this is, but we'll do it anyway. So referencing to the live side, and there we are once again, the 106 volts AC. So clearly there's no isolation here whatsoever. So touch that end, you're directly referencing yourself to the mains electricity, which in normal circumstances would be the earth. So touch either one of those, you're going to get some kind of a shock off of it. And again, that's the 50 Hertz actual mains frequency coming through. And notice it records the mains frequency even when it's not connected, because it picks it up through the wires. So that is that. It's no isolation, and touch the end of it, basically you're going to get a shock at or somewhere in the region of 110 volts. And if you touch both of the ends, of course, then you've got that 240 odd volts which may or may not be AC or DC. I think it's just really poorly rectified and non-smoothed AC personally coming out of there, hence it's showing up that sort of 100 Hertz as the frequency. Now let's have a look at the strip itself and how it's constructed. So this is the end where the power would go in, and it's fairly robust plastic material. So we've got these two conductors down the side, some kind of twisted wires there which go the whole length of the strip, and those what comes out the ends there, those pins basically just stabbed into there, and it's just secured with tape, and they go all the way down to the other end here, and as you see those twin conductors come all the way up to the end there, and although you can't see them particularly well on the end there, of course they're only sort of fractions of a millimetre underneath the end of that plastic tubing there. So touch the end, of course, very likely possibility of getting a shock from it, either between the two or from one or the other. And the LEDs themselves look through those sort of 50-50 variety. It does actually say 50-50 inside the tube there, and also got number 622R, presumably that's value of the resistors inside. Now, so we can just open this, see how these things are actually wired together. I was going to take the strip apart, but actually it's even more simple than that. There's two connections, one at each end, and as you see on the strip here, there's a wire comes across from that conductor there on the side onto the sort of tape in the middle, and then at the other end it's exactly the same, except it comes across from the other piece of outer conductor, again just soldered onto the tape there. So pretty much it's just power at each end. Now there's 60 LEDs on this strip, and there's resistors at various intervals, and these just those standard 50-50 LEDs as it says there, just 5 by 5 millimeters. And we've got sort of a pair and a resistor, a pair resistor, and then so on. And then we get to this part here where you've actually got 4 and a resistor, and then you're back to the pairs again. And then you've got another set of 4, and then it's a pair, and 4, and so on, and it goes all the way down. And as is typical with these tapes, there's a join here in the centre with this big knob of solder just shoved in there, but pretty much it just carries on all the way down the line. So there's no particular actual design involved in that, just simply a load of actual LED tape strips stuck inside a plastic tubing. So all that remains then is what's inside here. I think we can probably guess it's just a few diodes or something, so we'll see if we can pry this open, see what's inside. Well, I finally managed to get inside there. So we've got this outside white covering, which is a fairly flexible and bendy type of plastic. Inside we've got this solid grey plastic block, and the wires are actually moulded into this, so it's obviously poured on when it's hot or something. And then the only component inside is this black item, which basically fits in the top in there. It's just all moulded over the top of that. And this is of course just a bridge rectifier. Hence the 4 terminals. There's no markings on it on either side. The only thing we've got is little A and the number 2 there, but it's pretty obvious it's just bridge rectifier. So you've got your mains coming in, 4 diodes, and rectified mains coming out the other side. So no isolation at all, no smoothing of any kind, so hence that 100 Hertz reading out the side, as it's basically rectified mains frequency, which is 50 Hertz in the UK. So there we have it, just a single bridge rectifier, and no isolation whatsoever. So the tape itself is pretty much at the full mains potential. Touch any part of that and you get the full mains potential shock in your finger or whatever. And if you touch both ends, of course, you're getting basically rectified mains between those 2 points. So in any case, extremely dangerous. And the note that came with it, which says the tape was for protection and you'd better keep it when you use it. Well, at least that part was right, because if the ends fall off, of course, live parts are exposed. So clearly a completely unsafe and dangerous product. It certainly does not comply with any regulations relating to safety, and that CE mark on it is also a load of rubbish. Clearly doesn't comply with the low voltage directive for a start, and no doubt plenty of others. And whether it's lead free and doesn't contain toxic substances is another matter. I don't have any way of testing that, but I'd be very surprised if it's lead free. It's probably riddled with lead and cadmium and other disgusting heavy metals and who knows what. So pretty poor device there. Shouldn't be sold anywhere, and certainly not sold into the European Union. So until next time, thanks for watching.